But anyway, thank you. I know your time is valuable. We want to get started on this, and we appreciate so much your interest in the project and your willingness to come and spend the afternoon, part of your afternoon with us here today. How many of you, by a show of hands, are Waco High or Richfield High alums? Quite a few. Okay, let me ask a second question. How many of you knew there was a planetarium here? Most of you. Anybody not know there was a planetarium? A couple people didn't know there was a planetarium here, okay? Well, this planetarium was built in the 60s. This dome came in the 60s from a company called Spitz Incorporated, who's here today, and their technicians came when they saw this. They said, wow, we haven't seen a fiberglass dome since the 1960s. Shortly after this was installed, I guess they moved to aluminum domes, which the new technology is, which we hope to install in here as well. What you're seeing here today, as far as the aesthetics, is nowhere near what we're hoping to put in here. We've got temporary chairs, a concrete floor. This big contraption here in the center of the room was the old analog projector. This is not the original one. This was put in the 1980s, and it is even a relic. We'd like to put this on display as part of the history of the planetarium. And the new digital projection system that you're going to see a demo on today is actually mounted under the lip of the dome on the walls to give us more premium seating space in the center of the room. So just one of the advantages of going to the new technology. But we're going to put carpet on this floor. We're going to put these really nice, they're called planetarium seating. They're like the big high-back theater chairs that you go and watch at the movie, except they lean back a little bit more because you're going to be leaning back some to watch on the roof. And I'll see if we can find some Advil to give you after the show, so in case you got a stiff neck. So you folks in the back have a little bit better angle on it, but we want to really dress this up and put an aluminum roof on here where the seams are not available, are not identifiable, and it's also perforated, and that's so the surround sound audio can come through the roof, and also some of the air conditioning, and we've got that set down so it should get a little bit cooler in here. But all that is part of reviving the planetarium. We're also going to cut a door in the corner here into the room next door. It is a classroom about 2.5 times the size of this building. We want to put an interactive science exhibit in there for kids too. And the reason for that is because a lot of elementary schools and middle schools, when they send buses out on field trips, they want to send a big long bus with 70 kids in it, 75 kids. Well, if we can get 40 people in the planetarium and maybe as many as 44, 2 classes worth, and then the other half of the bus can be in the science exhibit next door doing interactive things, then we can switch them out. They can spend an hour in here and then an hour in there, and then we can put them in a new park that we're building out here at the dedicated entrance we'll be constructing. It's now the SPED entrance with picnic tables where those kids can also have a lunch as part of their field trip plans. And then what we would like to do from there, some people from TSTC were here this morning, the director of their Challenger Academy with the Challenger Simulator. We want to collaborate on an initiative with them and also with Baylor's Mayborn Science Museum where the schools can come here for a field trip and then have lunch and then go the second part of the field trip and fly the Challenger or go to the Baylor Science Museum. So it is a complete science day for kids, and we're talking about pre-K up through high school, even some college classes. And this is not just for Waco ISD. Our master plan on this is to share this fantastic facility with students across Central Texas. We're going to be starting a campaign soon to raise money so that most of this can be privately funded. And we think we've got to raise about $600,000. I will tell you, last week I got an anonymous donation. Well, it wasn't anonymous to me, a donation from a private donor who wished to remain anonymous for $100,000 to kick it off. Because they said, this is a great project. There was a Waco High alum, and he says, I want to see this happen, and I'm going to help. So that'll kickstart us. So with no further ado, I'd like to invite up to the front then Scott Huggins from Spitz Incorporated.
Our systems are designed specifically for education and for schools. And when I say that, I mean they're designed that way from a footprint standpoint. These are the smallest projectors on the market that deliver this kind of resolution. We're going to be showing you 2560 by 2560 pixels on the dome, much, much greater than any HD television or movie you would ever see. But the projectors are the size of a couple of shoeboxes next to each other, and they're also pretty affordable by planetarium system standards. Also, core to our philosophy about delivering a display system and computers to a planetarium is that they be designed specifically from the education standpoint. We start with education and then we make the technology around that. When I say that, what I mean is we're partnered with a curriculum company. They're called Simulation Curriculum. All of the software we're going to show you, the Starry Night software for making astronomy visuals on the dome, and the Layered Earth software that does earth science, are designed by educators, and they're specifically made for teaching. And the wonderful thing about that is there are classroom versions of all of this software we're going to show you that students can have installed on their workstations, on their computers in the classrooms. So if students do activities, if they do projects and create scenes in the classroom, they can bring them into the dome and show them here. If a professor or a teacher shows visuals in the dome here, they can drop those visuals onto the network. The students can go back to the classroom and tour the moon as we were touring the moon here, or land on the surface of Mars, or explore distant galaxies. So everything we do is really centered around education, and we'll show.
Holds amazing surprises. Dive into a world of hidden relationships that surround us.
At the center of an age-old mystery. Join an extraordinary journey that spans not only
From pre-Cambrian time. Join Bula, Zeta, Malto, Goya, Wizzy, and Wig as they blast into the past to solve the mystery and save Earth from a toxic future.
Are you certain this is a good place to dump our trash? I think this volcanic vent is about to blow.
Created for audiences of all ages, the Zula Patrol delivers a dynamic, focused, and fun learning experience.
Often when we think of the planetarium, we're thinking of a live presenter, somebody at the console, who's really teaching and interacting with the audience and guiding the visuals as we go along. In the old days, when we were doing that, the tool that we had was that instrument right there. It was a ball with a light bulb in it and a bunch of little holes in it. And when you have a ball and a bunch of little holes, what you get on the dome are dots, and that's it. Some of those dots, thanks to those little plates on the other side, were planets that could move around like the planets do, but what you really had was a whole bunch of dots, about 2,000 of them, and 7 little ones that moved around. We didn't even get up to 9 planets in those days. Another wonderful thing about doing all this digitally, pay close attention to what you see on the dome here as I move time forward. We're moving forward by tens of thousands of years every second, and what's happening is these constellations are distorting, they're changing shape. Why? The differential rotation of our galaxies causes our stars to swirl around and move. So this static star field that we think of as fixed and infinite is changing all the time. So this is the constellation patterns that our descendants will see 500,000 years from now. I think where all of this gets very exciting where teaching in a planetarium really opens up is when we start to move out into space and look at astronomical objects from different perspectives. So there's a lot going on here. You're looking at the surface of the Earth. To the left of us is the moon, properly illuminated by the sun, also to the left of us. If you look closely, the shadows are cast properly on the surface of the Earth. The sun is actually causing those shadows to elongate as the Earth moves along in front of us. And we're very concerned with technology too. If you look at the Texas state standards in particular, students aren't just required to understand what happens between the planets and why they orbit the way they do. They're also required to understand how technology has given us an understanding of the Earth. So we're now a bit further from the Earth. I have the orbits of the artificial satellites turned on, and every one of those satellites is a little three-dimensional body that we could fly up to if we wanted to. And we can even anchor ourselves to space missions. We're looking at Apollo 13. This is, I believe, April 13th of 1970. I'm sorry, April 15th as it's returning. And we're looking at the Apollo spacecraft as it's flying back from the Earth. And if you look closely in this area right here, that panel is even missing. It's blown out in the model. And you're going to see these occasional little jerks and motions of the spacecraft. That's not a computer glitch. Those are the actual rocket corrections that Swaggart and Lovell had to do to keep the attitude of the spacecraft correct. And I should point out, as I'm showing you this three-dimensional model here, these are not static pictures. This is a three-dimensional model that I can manipulate. I can move us around to where we're looking at the dark side with the sun behind. I can move us away so that we're getting further and further from Apollo 13. So we have live interaction with all the stuff. We can take you through space. We can fly you to different planets. We can take you out to distant galaxies. And the last couple things I'd like to show you in the astronomy world are the galaxies. As we get further and further away and leave our Milky Way galaxy, we also draw these galaxies with great detail too. This is a model that Dr. Dave Bradstreet and I made of the Milky Way. It contained hundreds of thousands of particles, all accurately placed within the galaxy. So you notice the lanes of dust moving through the arms. You notice the nuclear populations of stars in the center, little blobs of star-generating regions and gas that are called nebulae inside the galaxy. And Brad, why don't you put up the second one? Let's look at a globular cluster. We're now going to go way outside of our galaxy, many tens of millions of light years. This is what we call a globular cluster. It's a dense knot of stars that's in the arm of a galaxy. And Brad is going to back us away a little bit, and we're going to see this beautiful two-armed spiral galaxy that it's a part of. So as we back away, we realize we're actually inside a galaxy, and you're going to see these gassy arms of this galaxy coming up on the left.
We can watch, over the course of 2004, hurricanes form off the coast of Africa, see which ones make landfall, which ones veer off back into the ocean. And from this point, we have a couple other years to compare if we want, but we could then look at 2016 and see, okay, does this hurricane season match up with what we're seeing here? Is it different? Are we getting more hurricanes? Are we getting fewer hurricanes? If we want to take a look at an even longer historical period, we could take a look at historical tracks. So these are the hurricane tracks from the last 50 years or so. And we can see, okay, how often did hurricanes actually hit North America?
You've often seen zygote simulations because they'll take you inside the bloodstream and show you what happens inside the body as the blood starts coursing through your veins, or they'll show you the stress of exercise on the lungs. That was all the work of Zygote. And so we approached them and asked them if they'd be interested in developing a simulation suite for teaching about the human body and the dome. And so this is one of the two models. There's a male model for anatomy and a female model for anatomy. And one interesting thing with the actual male and female models, there was one person scanned to develop the entire body. And the reason for that is they didn't want a skeletal system of a very large-boned man and then the muscle system of a very skinny guy. The actual anatomical parts wouldn't fit together properly, right? They just wouldn't fit. So this is all one person who's been scanned, and in the same case with the female. MRI was used, X-ray was used, CAT scans were used, and so the actual interconnectivity of all the parts is very, very accurate. And then for the realism of the models themselves, a process called photogrammetry was used. Based on hundreds and hundreds, even thousands of dissections, all of these individual piece parts were photographed, And then photogrammetry is a process where the photograph is mapped to the outside of the model. So no matter how close we get up to the skeleton, you get really, really realistic detail because they're photographically texturing the model.